Now we're going to tackle capacitors wired in parallel and series. So we're starting to introduce our schematic diagrams here, and I've tried to keep those to a minimum. But this, in fact, right here is the symbol for a capacitor. Notice it's two straight lines, just like two plates. It makes perfect sense. I haven't used the battery symbol. I just drew a picture of a battery right there to avoid confusion because the battery symbol is very much like the capacitor symbol. But this is what we call parallel wiring. And it looks like this is parallel, but don't be fooled. Just because lines are parallel doesn't mean it's parallel wiring. When you combine capacitors in parallel, the electrons have a choice of paths. So here's my electrons are coming out of here, and they have a choice right here. There's a fork in the road. They either have to go right there, or they have to go right up there. In fact, they will go to both locations. And so if I'm going to call, let's say this is 1.5 volts right here. Let's label that 1.5 volts. So the top, again, this is plus 1.5 volts at the top, and 0 volts. Typically, we let the negative terminal of the battery be 0 volts. So what will happen is electrons will move on to here, or let's just use positive charges now, like I said I would. Positive charges are going to run over here and move on to this thing, and they're also going to move over here and move on to this thing. But what that does is that pushes positive charges from this plate over on the bottom, right over here. Those positive charges that are there are going to want to get the heck away, and they're going to want to move this way and get the heck out of there and go back to the battery. So what we end up with when we're all done is the same magnitude of negative charge on that and that. And let's just assume these are, these are just two equal capacitances C. So because at this point when there are no more charges moving, by the way, these things represent wires, they are conductors, and we assume that they're ideal conductors. They're perfect, they have no resistance. So that means that once this becomes to electrostatic equilibrium, there's no more net motion of charge. You should be able to tell me right now, what is the potential right there? V equals what there? And in fact, it's got to be the same right there too. Notice that this is connected by a conductor. There's a conductor right from there to there. So conductors are in electrostatic equilibrium are always equipotential. One more hint, this is a conductor. So you may be able to now figure out that the voltage at this point and at this point is 1.5 volts, and the voltage right here and there and everywhere on this bottom thing here is V equals 0 volts down here. So in parallel, we can see that the voltage drop is the same for our power supply right here, our battery. Delta V is 1.5 volts, and it's also going to be the same for our capacitors. For both of these, delta V for both capacitors equals 1.5 volts for both capacitors. So that is our parallel wiring. The electrons or positive charges that are moving have a choice where they go. That's parallel wiring. Series wiring, by contrast, is where the electrons only have one possible path. They're going to come out here and go that way and just end up on there. Again, let's go to the moving positive charge model. So my positive charges, they end up just moving over here. And what that does is that pushes the way these positive charges here. And what's left is the negative charges right there. Those positive charges have been pushed down here. And then this is, again, pushing away the positive charges here and sucking those positive charges to this point. That's where the positive charges have moved to the negative terminal there. So you end up with this situation right here. Now, interestingly, if my delta V is 1.5 volts here, the delta V across these, this delta V is not 1.5 volts. Delta V is not equal to 1.5 for this guy. But the main concept here is getting the difference between parallel wiring and series wiring. Parallel is where the electrons have a choice between those two, and series is where there's only one path for the electrons, or you could also look at it as positive charges like conventional current.